Avi Geiger is a super creative roboticist here in Seattle, and I got a chance to sit down and pick his brain for a while and share it with you guys. He built a company called PicoBrew a little while ago after a career at Microsoft making hardware. And PicoBrew was a way for people to do their own brewing at home, kind of systematize that. He built an entirely like automated factory for it. And I was always really impressed with the clever things he came up with that. And now he has a company working on making robotics much more practical to integrate with AI, meaning how do you get the language models connected up to the vision models? So when you talk to a robot about what it needs to do, how do you correlate that input to what it's seeing in the world? Avi's new company called Groundlight is building the toolkit you need to do that.
I've never met anyone like it.
He could hack anybody's phone in a matter of minutes. Who is that guy? Who can do that?
Thomas is the most interesting man in the world.
He's one of my favorite people on the planet.
Inventor.
Wicked smart.
The master of cutting corners.
If you had a dead body in your trunk, who would you call?
He would get arrested immediately in a lineup.
I stood in line to get his autograph.
You know, his mouth can barely keep up to his brain.
I don't actually know what Pablos does.
A hacker magician.
Man of the future. 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 Future.
No, Kara Walker, the artist.
It sounds familiar.
She's moderately famous.
Okay, yeah,
Does
not my department.
not your department. Anyway, whatever. There's a big installation at SF MoMA. It's insane.
But
Gorgeous.
what kind of stuff is it?
It's a lot of themes around like race and society and division of and anyway.
But
there's
paintings or what medium?
This is actually robots.
Oh, robots.
And so
Oh.
this a group in New York, Hypersonic, was doing the construction of it. And there's one of the robots, Fortuna. She is like 10-foot tall, animatronic,
Okay.
sculpted from clay and reproduced, and spits out these messages. I'm not going to call them fortunes, but
Okay.
they're definitely things to think about.
Fortune-esque
Fortune-esque,
messages.
yeah.
Okay.
And dispenses them 10 foot tall, and they flutter to the ground at the base. And anyway, it was one of those where like someone on a list or Slack channel basically posted like, hey, does anyone know how to get non-repeating messages down 660-foot roll of 1-inch wide paper?
How hard could that be?
You know, you would think so.
What's the hard part?
The hard part is that there's a handful of printers in the world that will do this,
Yeah.
like printer models that will do this. It's a single piece flow labeling problem is what it really is. And the funny thing is like we went through this for PicoBrew at the recipe kit factory. And so we went all in and made this crazy, amazing single piece flow, like Willy Wonka recipe kit factory. And part of that is like the last domino really was the printing actually, because we had basically a bumper sticker and then we had a couple other label stickers and we were laser marking all this other stuff in process and all the dispense was dialed and it was great. But we were still like stocking stickers and pulling them off shelves to get it on the right stock and the right this and the right that. And then you have these label printers, like even the, you know, we're going to go print your own labels. You want to print a roll of labels that are all the same or pre-programmed, maybe serialized, but we need a different file every 2-inch label. Not a lot of things handle that well. There's long pre-processing times and startups and it's going to clean between jobs and all these things. Anyway, so it's one of those where like, I know why this is hard. I know when to touch it. It's not actually that hard, but it's like, here's the 4 models of printers that'll work. Like what I actually ended up with one of those printers through whatever. And anyway, the long of it is I've been printing these things for them and delivering them to SF MoMA, which is just kind of.
Do you get to make up the fortunes or where do they come?
They're set.
Not your department.
Not my department. And they're actually kind of awesome. Like it's been I don't want to spoil it for
fair
anyone,
enough.
but like it's been a joy, just
Wow.
like very meditative. Some of them are like, ooh, that's stuff to think about. And it's been cool because my kid hangs out downstairs and works on this stuff and wants to help and reach out to me. He was like, oh, what is that? Oh, that's interesting.
Oh, good.
Yeah,
Wow.
it's really interesting.
So if you are in San Francisco and need some homework, you can go to the MoMA and get Carol Walker's robot to give you some
something to think about for sure.
Okay,
But
cool.
then it's also been printing these long rolls and all this web handling stuff. And it's funny, you get into all the esoteric things of like, how do you make sure a roll's straight and tight and doesn't walk and all these things. And I've actually gone back and a friend was like, have you read the Exact Constraints book? I'm like, no, I probably should. And it's kinematic machine design. And there's a whole chapter on like web handling and understanding how the web is actually part of the machine. And so all this cool stuff with bridging the intuitive knowledge and the theoretical. Like I have a reasonable amount of mechanical empathy. I can
sure.
look at things and figure them out.
Yeah.
And you talk to people who run the machines, there's the paper converter, and we're talking about, oh, why is it not rolling well? It should say things like, oh, you can put like one wrap of masking tape on one side of the roll so that it'll pull it to that side. And
Yeah.
it's like, oh yeah, because it creates just like a little bit of differential tension on the web. I'm like,
Yeah.
oh, you want your pieces close together. And then you can go reference that back to the exact constraints in kinematic design and be like, oh, right, because if the rolls are far apart, then the two sides of the web are it's basically a line, not a plane at that point. And you get into all this other, anyway. Whatever. It's been fun to think about along with the repetition of.
What amazes me is I've worked on some just roll-to-roll systems,
Yeah.
and alignment of the rollers is such a big deal. And I remember when I was a kid, we'd go on a school field trip to the
Right.
newspaper, and you'd see the big printing operation that the newspaper had. And paper, roll-to-roll, is flying through there at like 1,000 miles an hour, just hauling ass, printing. It's thin, shitty, non-structural. How did they do that? The amazing engineering behind newspaper printing is still
The exact
more and more.
constraints book will explain it all, actually. Yeah, no, it's wild. And so much of it is about like making sure everything is, well, exactly constrained, right?
Yeah.
Like things float in the right direction and not in the wrong direction.
Yeah.
And you don't, anyway, yeah. So
And what are the tolerances on newspaper manufacturing? How good could that stuff really be? I guess at some scale, everything gets
it's pretty good.
pretty good, but yeah, but man.
It's pretty good, but also a lot of it comes down to just like system rigidity too. It's funny, I was having trouble the first time I ended up building like a full splitter rewinder in the basement to do this. And the first time I built it out of what was laying around. I had a ton of 15 size, the smaller 80/20 rail, it's like a bucket of it. We're out the right size pieces, so I built it out of that. And I'm looking at it, like struggling with all these problems. This thing's just not stiff enough. And what really gave me that realization is I tried to build the 24-inch wide splitter on some bigger rail, and clearly a stiffness problem. And then I was like, oh, I wonder if all my other problems just come down to stiffness. And so I just rebuilt the thing out of bigger box section. Oh yeah, it just runs like a champ now.
One of the things I find that I built an intuition for is how not stiff aluminum is.
Oh my gosh.
And it's crazy to think about, because I think if you don't know or you don't play with this stuff, like metal's metal. It's like, oh, it's metal, that's infinitely stiff. And it's just not at all like that.
Yeah, and different aluminums.
Oh yeah, different
Different
aluminums,
structures,
I know.
and also just like the difference of cross section, right? Height cubed is, and don't pick up our fight with cubic.
I was thinking of like a example with the flitter machine. At some point, do you ever shave with a razor?
I don't look like I shave with a razor, do I?
You don't right now, but I was
No,
wondering.
not typically.
So Instagram is targeting me with this razor made by like aerospace guys who made a razor, and their whole video is about like how stiff the edge is that holds the blade in place. And then they show compared to the plastic razors that I'm using, and I'm like really tempted to buy that razor, which I don't need because I have plenty of really good disposable plastic razors to
Yeah,
last.
but like experiments, come on.
But I really believe that it's going to work better, and I'm probably going to buy it.
You should. Like, you should find out.
Well, I probably should find out.
Yeah,
Exactly.
I mean, for science, come on.
Oh yeah, for sure. So if anybody knows about that razor, send
Yeah, I don't know
send me
about
a review.
I don't know about the razor, but it's interesting, right? Because you have your compliant skin, and it's probably
Right.
and like I feel like there was a whole era where we were marketed to
Razors that flex.
Exactly.
Exactly, yeah.
Right. Like I feel like Gillette spent billions of dollars telling us
That we
flex.
should want the razor to flex because they can't afford to make one that wouldn't.
I don't know. Yeah, no,
I don't know.
stiffness is wild. It's kind of tangential, but on the stiffness thing, I was listening to, what book was it? I think it was the Skunkworks book, and they're talking
yeah.
about building planes and whatever else, and you're talking about aerospace structures, and one of the cool things, like they talk about loads in PSI, right? And I feel like that's specific to aerospace.
Yeah.
But it's such a cool way to think about something in terms of when you think about materials and cross section. And
Yeah,
load.
because it's a ratio. And I think that like what people get wrong in life is they want to think about, even most people don't want to think about numbers at all. The ones who do want to think about real numbers, they don't want to think about ratios. And like ratios are just what matters in everything.
Yeah.
And I think almost every number in your head should be recontextualized as a ratio. How much money you make is like, how much do you make? What's the ratio between income and your budget? That's the number that should be in your head. Doesn't matter how much you make, it matters how much you spend versus how much you make.
It's empowering. It gives you control of the variables, right? Like when you think about the load as like, oh, there's 2,000 pounds on this pivot. Well, there's okay. What does that mean? Oh, there's so many PSI. Like force doesn't break a piece of aluminum, for example.
Yeah.
Pressure does. Tensile strength is expressed in PSI. Or 1,000 psi, right? And so you go and you say, oh, this is how much psi on the joint. Great, how close to breaking strength is it for the material? I can change the material, I can change the structure. It gives you the variables that you should be optimizing right in your hand. It's not, oh, I need to change the load. Like I can reduce load, change materials, change the shape.
Yeah.
Awesome. Like,
Did you up the term biomechanical empathy?
mechanical empathy? I don't know.
I think I would have to be in Seattle to hear somebody come up with it.
I don't know. I think a friend of mine might have coined it, but yeah, no. Mechanical empathy, like horrible with people.
I think it's a uniquely good use of the term empathy. So can we talk about this giant robot you made to brew beer?
Oh, beer robots. Those are tiny robots.
Oh, they're tiny
You
robots.
said robots. I thought you were going to talk about current robots. We should talk about that too.
Yeah, we'll go.
But yeah, beer robots. I love beer robots.
Do you love beer?
Uh,
Or did you before you started the project?
I do love beer, but I love it from a food and taste and exploration standpoint more than anything else.
Yeah.
It's just this like incredible range of what you can make, both in terms of the input and how you process it, and when you get sciencey about it, you can really dial all these profiles. And conventionally, home brewing, especially at the time, was just like pots and pans and science PDMs. You can spend years and years getting great at it.
The way people cook at home.
Yeah, exactly. Right. Brewing should be baking, not cooking. Right. Like if you're brewing or you're baking, sure, fine restaurant cooking is a different beast, right? But that's like when to the home analog, like it's more.
Right, because you have these fermentation cycles and things.
Yeah, and just the extraction cycles, and like time and temperature really matters, and how long it takes to heat, and
But okay, so basically, the point of the company was to build the equipment to systematize home brewing, so people could do that at home. Is that really what the goal was?
Yeah, give or take. In part, yeah, to be able to create like exactly what you wanted, at scale that let you do it exactly what you wanted. Because we're limited. There's tons of choices out there in the world, made in large batches, like average flavors. And I want to tweak it exactly this way. I want to create something. And then also, one of the interesting things about beer too is that it should be fresh, right? There are beers that age, and there are beers that are designed to age whatever else. But most of the beer we drank, especially what was this popular at the time, IPAs and things like that, like those want to be fresh, like really fresh. And that's why a lot of things weren't packaged. And also moved to cans from bottles too, but a lot of beer isn't packaged because by the time it goes through the supply chain, it's like...
Where's the cliff on freshness for something like you're describing? Like days or weeks or what?
Depends who you talk to. And I'm sure someone's going to hate on it, whatever you say here, but I like to think of it as like most beer, 2 weeks for a lot of beer.
So there's a reason people would want to go to a brewery and
absolutely.
have the beer. Oh, interesting.
And also like you go, I'm spacing on his name, he runs the brewing department, like Davis.
Okay.
Awesome brewing program. I want to say it's Charlie.
UC Davis?
UC Davis,
okay.
Yeah. And I was like, you guys asked, what beer do you order at the bar? You just walk to the bartender, what beer do you sell the most of? Great, I'll have it. It's just like, that's going to be the freshest can. Especially for hoppy beers, it's a real thing.
Okay, I'll put my cards on the table here.
Bring it.
Never had a glass of beer or can or bottle, but I'm really interested in cultivated foods. I think we should make all the food in the world the way we make beer. All the meats can be grown in vats the way we make beer. And the problem we have right now, it's so fascinating, is that in beer, what you're describing, what you worked on, is going from industrial scale, massive vats, down to small lab scale so that we can do it at home. And the problem we're having in cultivated meat right now on the other side is going from lab scale up to massive scale. So I'm curious whether we can find any lessons from your experience that might help us go the other way.
The interesting thing is like most of what we did in the beer robot really wasn't the it was the brewing side.
All right.
Because it was really what we create in that fermentation process, we're not making beer, we're making alcohol. That's what's happening in fermentation is like we're going to convert sugars to alcohol.
So that's really, so if that's true,
taste,
that's the point is what you're saying. So you're just making the alcohol.
No, the fermentation part, the part that's analogous to growing meat in the vat, that's really just doing a starch to alcohol conversion. The brewing, the hard part of that is actually getting to that fermentation. There's stuff in the fermentation too, and we did some pretty interesting stuff, and I guess some of it just comes down to like it's the right yeast, and you can ferment under pressure, and there's some weird tricks you could do, but now you're into the more like, how do you control the bioreactor? There's a whole different set of things.
Okay, that's not your department. But let me ask you this.
We got in there, but
Sure. If that's true, then why can't I just do the brewing, get rid of the fermentation, just add alcohol?
You end up with something that tastes different, but you get different tastes as the...
Why would it taste different? I mean, if you're just ending up with alcohol anyway, it's more like if you did a mediocre job of making alcohol, that would affect the taste in some way that maybe people like, versus if you just use alcohol as an additive.
So you can't... So when you're doing extraction from a natural product, I'm a little bit over my
That's fine.
my skis.
That's
on this
fine.
one,
Fair
but
enough.
I'm just gonna we're gonna try to wing it here. Like when you're doing extraction from a natural product, you get everything. Right?
Yeah.
So you steep in water, you get everything that's soluble in water. You steep in hot water, you get different solubility. You steep it in, I don't know, toluene, you get whatever's soluble in toluene. You get all of it out, and then now you have all of it. So if you steep that grain in water, you would get grain soup, and then by adding yeast, it converts a lot of those sugars to alcohol, but it converts some of it, not all of it, and there's enzymes involved too, but it converts some of it, not all of it, and you get, I don't know what the right analog is, because you're not doing selective extraction, but it's you're converting some of it, leaving others of it, and so you have, you're taking parts away. You couldn't do out of conventional extraction.
Yeah, so it's whatever those other things are has some bearing on the taste. And
what's wild too is like how you do your extraction controls like how much enzymes happen, like time and temperature, and will control how much gets converted too.
For
the
sure.
Sweetness and the thickness. And I remember one day, it was just like early on, we do these test batching. So Jim was the food scientist in the bunch. He's super cool dude. Like his grandpa invented Pop Rocks and Tang and like all that. And he grew up like in that.
his grandpa invented Pop Rocks and Tang.
Yeah.
Cool. That's my entire diet.
Right?
I should meet this guy.
Yeah, and Jim's, it was awesome working with him. It's just like wild food scientists who do this crazy stuff and be like, oh, do you want me to build a machine so we can just carry the things and do it? We can do that. I'm going to go next door to the shop and we're going to build it, and I'll be back in the afternoon.
Okay.
Yeah, it was magical. And but anyway, like early on, like something was wrong with the temperature sensor, and we brewed, like it had the consistency of syrup and like thick syrup, but the taste of completely normal. And you're just like, oh wow, we created all these weird long chain sugars. Just like all these little changes with the same ingredients, and that for me was just fascinating.
Sure.
And seeing customers do it too, like the first. I think was one of the first people we delivered a machine to, and you read their brewing notes and whatever else and see the first time they did it, and they're like, oh, changed this temperature by half a degree for this amount of time to increase mouthfeel in this way. And I'm just like, and just, oh my God, we turned on an incredible tool.
Wow,
So,
super cool.
anyway.
But you could have taken that syrup and put it in a fountain Coke machine and just,
It wasn't sweet, but yeah, no, it's cool because we also, once you're into brewing, like time and temperature, like there's coffee, and like we got deep into coffee and kombucha. We did a ton of kombucha stuff, and yeah, it was fun.
okay, cool. And then what was the robotics part of this mainly doing? Like just trying to production and fulfillment, or?
Oh, there were two sides of it. So the fulfillment center was awesome. We talked about that, but the machine itself was really about pumping fluid to the right place at the right time. So we had some clever arrangements of compartments that allowed the right kind of cascading overflow, a bunch of patents, whatnot for that, and then valves that would be robust and cheap to make and do the right things in the right small space. And that's, And we got, it was a cool arc of the one-off commercial machine, prosumer type machine, and then consumer machine, and then taking all the learning from the consumer machine and putting it back into the next gen professional machine.
Yeah. All right, cool.
Yeah. But the fulfillment side was the thing is like you want to be able to produce. So for the consumer machine, we had recipe kits, and we went and developed like deep drop compostable packaging, all the stuff for it, and that was a pretty fun first principles exercise in and of itself. But
wait, what kind of packaging?
So it's bagasse compostable, but it was just a shape and scale that like started fashion, like call everyone on the internet. No one's like, this should be able to be doable.
Yeah.
No one can make it.
And you figured it out.
Well, sort of. I mean, we did, but with help, of course.
Yeah.
And so we're like, maybe we need to make our own pulp line. Like first principle says it should be possible. And eventually you start calling and looking at what that looks like. I guess that's what our next part of the business plan is. And you get to, like, could you make a machine like this? I'm like, oh, great. Have you built a machine with these parameters? So like, yeah, there's two. Cool. Can we know where they are? I'm like, oh yeah, happy to enter you. And went to middle of nowhere, far away place.
Yeah. So you ended up with packaging that was compostable. What's the status of this packaging now that I put in it?
Company's defunct. There's none exists.
Yeah.
But it's similar to a lot of other compostable packaging. It was just being able to uniquely do it at the shape, and we did a lot of things with laser cutting, like filter beds, and being able to have this one process that rolled through the factory, but no matter what you did ingredients wise, we could dispense. It was a beautiful, the thing was just like a beautiful state machine and self-calibrating in a bunch of ways, and buckets would roll down the conveyor and be scheduled to get dispenses from everything down the line, and they would know at the end whether there were things for manual dispense, so it was cool.
So the company's not around. I can't get one of these home brewing machines anymore.
I mean, they're on eBay, but
I can't get the I can't get the recipe kits.
No,
from
you'd have to
Yep.
you'd have to roll your own.
You
Which
do,
there's
yeah.
an
A lot
awesome
of people wanna
community
do,
for it
probably.
online. I mean,
Yeah,
talk
but-
about you have all these things like, oh wow, how much trash did I just put into the world, right? Like when a group of people actually cloned the whole service, and you can get I lit it up the other day. I was just like, here's a Raspberry Pi custom build. You download the SD card, plug it in, wait. It comes up with a Wi-Fi network.
Oh, wow.
You log into it, and and they've extended it.
Great.
So they've added
Yeah.
all these other things. Anyway, whatever. It's cool.
That's really cool. See it
But yeah.
have a life of it.
Yeah, the robotics side was not super complex.
Yeah.
It's the way I think about that robotics, right? It's making a factory and condensing a factory, right?
Yeah.
Like we're taking a process, like we want to give you the same control you'd have in an industrial factory. We're just shrinking the factory.
Yep. Cool.
So,
Amazing.
yeah.
I hope to do that for meat ones. Grow meat at home.
Oh, I think.
I'm kidding.
Yeah, why not? I don't know. I think we got a lot. I don't. Yeah, we looked at all kinds of crazy stuff with fermenting too.
Yeah.
And like doing small scale bioreactor stuff. It doesn't feel that hard. There's stuff that matters at scale, and I think also like there's some, who knows, like which of these stories are like real and apocryphal and whatever else in the food industry. But there are a lot of weird ones where they're like, oh, we made the process work at this, and then it didn't. We scaled up the bowl and like it didn't work, and we shipped the first generations of product on 400 KitchenAid mixers strapped to the factory. Or I think there's one about the Vienna sausage factory and being the length of they reorganized the factory and like the stuff was the wrong color, and it had to do with when they would transfer everything from building 1 to building 2, and that time turned out to be critical to the process.
Wow.
And into the color that the
Wow.
Yeah. Anyway, bunch of weird. It's all the stuff that you don't know that you're doing
Yeah.
because it's complex. I
Yeah,
love
yeah.
that about food. It's complex.
Yeah, that's true. Complex, not well understood in a lot of ways.
No.
And so it lends itself to old wives' tales and tradition, even if it's not understood, we just do it this way.
Which,
Yeah.
I mean, old wives' tales are often, some of them are crazy, but
Yeah, a lot of them have some useful knowledge in there, we just don't understand why.
Yeah, there was an old, I don't know, did you ever go to the Museum of Jurassic Technology? I have no idea if that place is still around.
Oh, that sounds familiar. I think I have been
It
there.
was in like Culver City.
Yeah, that's the one, and there's like some like weird tar pit there it was built on. What was that thing? That was-
I think it's La Brea Tar Pits.
Oh.
But that's different. But yeah, it's a funky little place, but they had a super cool show of old wives' tales, but then
Right.
stepping into science. And
Yeah.
yeah.
Cool. So what are you working on now?
Robots.
Oh, okay. Good. More robots.
More
We need them.
robots.
I think it's a good time for robots.
I love robots. It's funny. I think it's a robot company disguised as a computer vision company.
Oh, yeah. Okay.
Is really what we're doing. And so Leo and I kicked around a lot of ideas for what to do in the machine learning and robotics space, because I want to do something more machine learning focused. We want to do something robotic focused. I'm like, great, let's do this. And we actually started out just on the much more pure robotics and saying, hey, we're at this cusp where robots do parkour and they dance and all these things, but super scripted, right? But the mechanical control problems, like, they're done, right? For a lot of classes of robots. And there's lots of cool stuff happening, but anyway, that stuff exists. But then what do? We can script them, because in the real world, things happen. And how do you
Okay.
deal with
So this is really interesting, but just back up a minute.
it? Yeah.
Robots of the 90s versus robot today with machine learning. How would you describe the delta? How they're built, how they're programmed, what they can do?
Well, so there's today, and there's what we think is the near future.
Okay, sure. That's
And they're both pretty interesting.
Yeah.
Robots of today are, in a lot of ways, robots of the 90s.
Yeah.
Still, and the things we use machine learning for on them there's lab stuff and research papers and whatever else, but like the things we use machine learning is we do a whole bunch of stuff in simulation, learn something that works, and then translate that back into a 90s style algorithm to be able to do it.
Interesting.
Disney gave an awesome talk about this recently at a couple of robotics conferences, and just you do all this, and they do that for floppy robots, like robots that are like very hard to. Your robot's rigid, you can just use the simple math. If the robot's floppy, weird things happen, and how do you find the right control modes? Boston Dynamics does this that's how they figured out their slippery surface walking mode.
Okay.
And but most of it until that is just like conventional control stuff. And then there's the how it moves part. There's also what's it going to do? And there are a bunch of approaches to that. Right now, it's still the 90s, right? Like robots operate in factories, controlled environments. That's it. And then how do we break them out of that? There's a ton of work in, hey, we're going to do, some version of pixels to motor torque, giant ML model. It's going to happen. And there's all this moonshot consolidation There's a bunch of moonshots going at this from slightly different angles, and the interesting thing is, like, I think most of the hardware stuff is pretty sorted, right? It's actually
So we know how to make arms.
So we want to capture the whole value pie, right? And do that. And I'm not going to say if it's going to happen, but there's a real question of when. It's been 10 years away for a long time, and there's a real question of like how good it's going to be and like when it's going to be good enough in various ways. And you can like throw darts at the like various forms of AGI dartboard, but like that's. And then you have the other side, which is, hey, we're going to control the environment and do that. But what's the middle ground, right?
Let me ask you another way. It seems to me like all of robotics becomes just a camera and slam with the big model. What am I missing?
You're missing that's how it navigates.
That's how what?
That's how it navigates. But then what's it going to do?
Okay.
And the camera and slam problem, I'm not going to say it's solved, but
it's pretty close to solved.
It's pretty
like that's what a Tesla is doing, right?
Exactly.
Okay.
And so, for the cost of some number of barcodes hanging in your life, like it's solved.
Okay.
But then what's it going to do? And so the Boston Dynamics robot's a great example of this. You can go send it to patrol a loop around your facility and go walk around and take pictures. But it's still you're loosely teleoping it. You're now going to inspect these things. And sure, people do gauge reading on real specific applications, but you're roughly teleoping it, right? And there's huge value in telepresence, but why isn't it just always taking laps and checking if the fire extinguisher there and everything else? And we know what we want it to do. And you realize like we're actually pretty good at programming, right? In general, but there's a real magic to finding what's the right abstraction.
Okay.
And so, yes, we can say robot take a lap. And what you want to be able to say is robot take a lap, you don't have to say robot just go figure out if stuff is wrong. Yeah, great, okay. But robot take a lap, I want you to check if the fire, go here, look at the fire extinguisher, tell me if the fire extinguisher is there and it's not tagged out. Go here, make sure the door is locked. Go here, make sure there's no spill on the floor. That list of things, and to do that today, you just can't. And so...
Wait, why can't I?
So you want to go build a model for, is the door open, right?
I see.
You could go train a model custom for your door. Great, awesome.
But is
you could go,
is it this kind of door? Is it this kind of door? Is it that kind of door?
And that's what happens. Or you go and you say, hey, we're going to approach this like the autonomous vehicle industry, and we're going to put billions of models into develop. And also the other problem is no matter how good your model from pre-trained data is, it is what it is, right? And what if the world's different? And and this is where you can look at all this stuff with LLMs and say, they wrote you something mildly inappropriate or tripped over its words. People do that too, like whatever. But physical world robots, real consequences. And sometimes you want to know, and like, how do you bridge that gap? And so what Kat again said is this model is only going to be as good as its data. If you're stuck on the data from the past, that's how you learn. But how do you integrate new data? And so we said, hey, another approach, like instead of needing a right now answer, what if you wanted a right answer and you didn't care if it was right now? And let's say this world is connected, which it's pretty connected. All of a sudden it opens this new path and we'll say, oh, if our models aren't sure, previously models would say yes or no because there's no recourse. Like what's it going to do?
Just make the best guess.
And ours will say, oh, I want X confidence, model's not sure. It'll actually escalate to bigger models. And if they're not sure, it'll escalate to humans. And in real time, if 25 seconds, we'll take a human answer and that gets instantly trained back into the model. And so it learns your door.
Wait, this is what you're working on now?
Yeah, this is it.
Oh, cool. And then what's the target, or do you even bother defining what's the target use case, or what are you trying to apply this to? Or are you just trying to make a toolkit that can do this?
We built a toolkit that can do this.
Yeah, okay.
Like it works. And so with one line, you can say, is the door open? Send an image and get an answer.
Okay.
And every time you send it an image, that answer is going to get better and faster.
So if I have a Boston Dynamics humanoid robot, camera and slam wandering around, can get itself to a door, but the whole job of test the door to see if it's open involves a lot of deeper questions that it's not trained on. Is this a door? Does it open this way or that way? Do you turn the knob, or do you pull a lever or a switch, or do you push a button to open a door vertically, like with whatever, garage doors or something? So there's all those different things. It doesn't know. Like it doesn't know that button controls that door, whereas like a human would take it. So what's going to happen is the thing's going to show up, it's going to find the door, and then it's going to say, oh shit, this looks kind of like a door, but I've never operated this kind of door before. Escalate. And then it escalates and you say, here's a model that knows doors and doors and doors, and that is this type of door, and you open it by pushing this button. And if it doesn't know, because we found some like esoteric Frank-Lloyd Wright door, then it goes, oh, hand it to a human who can figure it out, because they're humans and they're smart, and then in 25 seconds or less, tell me what to do. And I say, yeah, just scratch your nose and rub your belly and pat your head. and then the door will open.
Yeah, and we're focused right now on the perception part of that, of just understanding that the door is there and is that a door,
Yeah, okay.
right? And action comes later. Yeah, but exactly, right? And actually the first version of the company was like full on to, oh yeah, we're gonna go straight to action, behavioral control.
Okay.
We're borderline too early on the perception side in terms of like where the robotics industry is matured.
Oh.
The action side is, I mean, you and I live in the future a little bit in our heads, but we're not.
Yeah.
We're a little
So-
further out than that.
So that border, if you're borderline, what's the border? We don't know for sure how to make this work, or it works 80-20, or I need a giant supercomputer.
The border.
and then I
Oh,
can
the
do it.
border for our stuff is we're there today.
Okay.
Oh, I'm talking about the border in terms of there aren't thousands of humanoids robots, or we don't have a bunch of robots roaming around to deal.
So your training data is lacking.
Yeah, and we can move to the action side when it's time, but the perception side, the interesting thing is like there's actually use for that today, right? Like all these same problems, like you can look at expansion of robotics and you start with, hey, robots work in really fixed environments. Well, where are we using robots that the environments aren't as fixed as we'd like?
Yeah.
And that actually includes industrial manufacturing today, right? Where someone can put their coffee cup down in a work cell. Like you look at all the cobot stuff. And so we have a partnership with Universal Robots to do fixture checking and scene safety and all the things.
Coffee cup extraction.
CNC works awesome. Did I load the right fixture? Because if I didn't, I can make a $50,000 mistake when I hit the green button.
Right.
And being able to check in all these places where humans and robots work together.
But it seems like training data could just be like GoPros duct taped to humans.
We don't even need to do that.
Like they're like pretty humanoid.
Yeah, but there's the thing, it's like we're already in a domain where the robot's programmed to do the thing.
Yeah.
It just needs to know, are we clear? Is everything is
Okay.
everything set up for me?
Yeah.
And that's already a huge one.
Okay.
And then the thing too, again, we don't even need cameras duct taped to humans. We have cameras out in the world, right?
Yeah,
You look
okay.
at something like, talk about that Boston Dynamics example, robot patrolling a facility, guess what? You can also just hang cameras in facilities.
Yeah, right.
And ask the cameras, right? And eventually it'll be easier to have a mobile robot do that than the
Mounted cameras.
mounting a lot of cameras, but we can do that today, and we do.
Okay.
And so there's how do we help robots in environments that aren't perfect?
Yeah.
And then how do we understand environments that robots will roam in the future?
Yeah.
On from there.
Is there who counts as a customer for you now or in the near future? Who should you guys be trying to get to use this system you built?
For starters, anyone building, the ones that we're most excited about for sure are people building robots that are building the future, right?
Okay.
We have a unique view on how to power it in like a really pragmatic way that works today. And then
If you are building a factory with humanoid robots or any other robots.
they don't have to be humanoid.
Yeah.
I mean, there are a lot of compromises that go into this whole
okay,
arrangement.
fine, right. So if you're building a factory with robots and you want a modern control system for them, basically.
You want to understand the world, right?
Yeah.
You want to be able to understand the world and take action based on an understanding of the world, like a semantic understanding.
Yeah. But is there some puzzle piece missing that you guys don't provide then? Because it seems like you would have to integrate with whatever software they're using to control their...
Yeah, tons of integration stuff.
Yeah.
And like you choose your integration points. So for example, in the industrial robots, you would call and say, oh, hey, is the scene set up correctly? And then escalate or
so
for
it could just be
inspection.
an
And that's
orthogonal.
honestly the first place is really that it's getting used is high mix inspection. And so you like flexible manufacturing, maybe able to do high mix inspection, process control. If you want to set up robot machine tending, which I have, right? Because like, how do you make your holiday trinkets while you're on your Zoom calls? You get a robot in front of your CNC. But the problem with doing that is it takes, I don't know, an hour to fold up a little chute and set a couple pick points and say, great, grab a part from the chute, drop it in the vise. Awesome. And then 20 minutes into running, you're gonna find out like, oh, one of my parts had a weird burr on the wrong side, or I loaded it backwards in the chute and like something tipped and then the gripper crashed and something bad happened.
Yeah.
How do you know? So you can sit there and watch it, or in this case, the ground light says, oh, does this look right? And after a few, you say, yeah, no, that's fine. And then it says, hey, this is weird.
Yeah.
What should I do here? And then it means that after you've been running for 20 or 30 hours and the chips have started accumulating in the door track of the machine, and so the door opener doesn't open once on a cycle. Instead of the robot trying to punch its way through the door, which realistically would have broken the end effector on the robot and would have been hours of fixing, it said like, hey, I'm not sure this door is open. Is this door open? I'm like, oh no, that door is not open. Thank you for stopping. And I can go over there, clear the track and go. And so it's this unlock for how do you turn on automation and have the confidence that it's gonna work. Because like today, like if you're CNC machining, right, like those are robots for sure, right? But It's not robot feeding robot. There's a people tending the robots. And if you're a job shop and you want more capacity, what do? You get another 400 square feet of floor space and buy another $500,000 machine and put it to work the same 8 hours a day. Like the amount of GDP that is locked up at night is just unfathomable.
I know.
Unfathomable.
That is so fascinating to me too. My whole life I've been obsessed with this. I grew up in Alaska and we would have a rock band, but there was nowhere for a rock band to have a show. We had to make it from scratch. Like we had to make we had to get a PA system, find an old warehouse that somebody would let us into, legitimately or otherwise. We had to go there's no internet, so we had to put posters up around town. We had to call all our friends and leave messages on our answering machines. It was primitive. But I guess the thing about it is, while I'm doing all this, I'm like, every fucking elementary school has a gymnasium with bleachers and everything. Right. Or they have, in the high schools, all have theaters and like with sound systems and like all that's built in, and we're not allowed to use it. And then I just started looking at like the utilization of an elementary school. Oh, yeah. It's like 6 hours a day and for 8 or 9 months of the year. And the rest of the time it's just sitting there empty, and we spent billions and billions on these things. I don't know. I'm so frustrated with the underutilization of everything.
Everything.
Yeah.
Wait, where in Alaska are you from?
I'm from the big city.
Oh, I was just there last week.
Oh, really?
Yeah.
What were you doing in Alaska?
We have family out there that we love. And
family in Alaska?
Yeah, family in Alaska. In the summer they're out, and my kid is really into otters, sea otters.
Oh, wow. Good, good, yeah.
Favorite animal. So we went out, they live out in Halibut Cove in the summer. And so.
Okay, yeah. I lived in Soldotna when I was a kid.
Yeah.
So
drove right by there. I think we might have actually stopped there to take a Zoom call on the way.
Yeah,
better signal than much of that highway. But yeah, no, we're out just paddleboarding and putting around and going hiking. I don't know. I love it out there.
It is an amazing place.
Yeah,
it is an amazing place. Yeah, anyway, so I think you're right. What you said about the staggering amount of GDP locked up in these factories and places at nighttime. And if we unlock that, it's like you could triple output for free.
It's so positive sum. And like the places where it doesn't work today because of risks, and like it's just like the risk isn't worth it. I mean, a lot of
I see.
It's like,
I see what you're getting.
What happens if you get this machine? Like, what happens if you break the machine?
Yeah, you would still need the whole team of people to be there 24 hours a day, watching if the end effector gets broke and replacing it and all, and unjamming one thing or another.
Breaks, right? Even a part loading is perfect. Like a tool breaks at night. Yeah. What happens? Like that doesn't cut something, so the next tool hits material that wasn't there and breaks.
Yeah. And so what you're saying is, you guys can go in, you can deploy. The factory runs all night. If something goes haywire, it escalates, and eventually it calls and wakes up the foreman.
And like it's what you actually want people to do too. And people often don't, right? How many things are like, when this thing was weird, you could have just like hit pause and raised your hand.
Right. And if you are the manager of that factory, your job is to like, go golfing, we'll call you if we need you.
Yeah. Text message like, oh yeah, thanks for stopping. I'll be there in a few.
Yeah.
Right. And
I love it.
Perfect. Or sleep, because it's at night.
I think it's just a point that we can't overemphasize, like, how valuable it is to be able to switch to advanced modern automation. What I love about it is that, my perspective on this changed over time, because I originally thought, okay, we did factory automation in like the 80s and 90s with like, in 60s and 70s with like electromechanical stuff, and then in the 80s and 90s we got some electronics to do sensing and monitoring, and so we could make like more automated factories, but they're all very bespoke, single-purpose automation tools. And then what I thought was that, like with 3D printers as a prime example, we would make them programmable. And you could make a factory that didn't, you could build the factory before you knew what you're going to make. And the machines are programmable, so you can just have them make whatever's needed at the moment. And that has taken a long time to sort of play out, and we haven't gotten as far with it as I would have liked. And what I thought we were going to do at the other side of this, the geopolitical side, is like, okay, well, once we get that working, then we'll be able to make factories in the US that are fully automated.
Yep.
And then I realized, oh, China's just making the robots, and they're automating faster than we are, and they already know how to make stuff, so they've got a huge lead on us. So I think there's kind of we've been kind of stymied on this, and I didn't totally realize, but I think maybe the reason is what you just built.
Yeah, this is the thing. Is like
This is the thing that's been missing.
We've been quietly doing it, right?
Yeah.
Like we've built like why do people get 6-axis robot arms to tend a machine? It's not a 6-axis problem. It's very rarely. Like it's a 2.5 axis problem
Right.
usually, right? And like what? But it's flexible, and we don't know what we're going to hook it up to later, and we
Right.
don't know where it's going to be and whatever else. And so yes, there's choice of end effector, but there are some fairly generic cells that handle large classes of products,
Yeah.
right? And you can look at, you think companies like Bright Machines or someone like that, who like they have these very similar cell that they kind of stack and stagger, and it handles a large class of products, and like they quietly runs in the background and great. But each one of those does have to be programmed, and there's still a big programming
Right.
list.
So
And then,
when they go from making like a bicycle to a microwave, they have to reprogram and reorient the same set of machines, but they reprogram them, they configure them, they line them up, they make a different product, and it might take them something measured in weeks or more maybe to retool. Whereas what you're saying is we just line up the machines, we give them all this sense of perception. We maybe don't make an optimized factory line, like, okay, you got to stick the wheel on the bike, so we're going to have a robot pick up the wheels from the west end of the warehouse and carry them over to the east end where the frames are, and then we're going to get a third robot to show up and bolt them together. But they're able to go do all that, which they aren't right now, because along the way they're not going to stumble over somebody's.
And look, you've built hardware products, right? If you were to take a ratio of the time between how long it takes to make a prototype versus how long it takes to ship it, it's huge, right?
Right.
We basically,
because I have to build a factory in between.
You have to build a factory in between, but imagine your factory is the thing you're prototyping, right?
Yeah.
You can go build those machines, and again, you can teach the robot in 20 minutes to go pick the part from point A to point B, and then you can spend the next 3 months working out the reliability issues around stock utilization and everything else.
Right.
We make that part go away. Right. So we let you just like, great, like program it, focus on the programming, tell it what you want it to do, what you want it to be looking at. And yes, we have sensors galore, but I guess the problem is they're actually not bespoke, right? You make a bespoke combination of sensors, but the sensors themselves aren't bespoke. And so vision, we think there's a way, like you should be able to have a bespoke sensor. It's not, hey, is there
in some cases
right, like it's not like, oh, there's a line laser and the box is there. Like I don't want to know if I want to know if a box is there, right? I want to know if 2 boxes are there. I don't want to know I don't care if the line laser is blocked. I want to know if their box is there.
Yeah, there's I guess as by analogy, you could say like, if you are Nestle and you're making, Kit Kat bars or whatever, you have a factory designed end to end, possibly with no computer chips in it, that just makes Kit Kat bars over and over and over again. And every single thing is dialed in, the temperature is controlled, like whatever. Whereas like, if I'm gonna go in my kitchen and make a Kit Kat bar, like I probably have all the tools I need to do it. I haven't really thought about it before. I'm gonna download a recipe off the internet. I'm gonna like open some drawers, rummage around, find the measuring cups. I'm gonna find like a pan. I'm gonna just start, piecing stuff together, because that's a prototyping shop. That's a kitchen. A kitchen is a prototyping shop. And even though, and I might not have the optimal thing, but I know I'm gonna find a thing that's gonna help me make all the parts of the Kit Kat bar. And I think that's kind of, if you imagine like, okay, what if we had a large scale factory that was built like the prototyping shop, where like all the stuff is there, all the tools are there, we don't know what we're making today, we just show up and dream some shit up. We're like, okay, we're gonna make a bicycle that looks like a Kit Kat bar. All right, great. Now we're just gonna go like grab all the tools that are around, do it. And that would be unfathomable to the guys who built the actual Kit Kat factory.
Oh yeah.
But not unfathomable to anybody who has a kitchen. And so it's really kind of like scaling up in that mode.
And it's scaling up it's like, how do you teach, right? And so the same way you would, like, we could go in the kitchen and hack something up and then show a friend or like, so, show someone else like, hey, here's how you make the thing. Yeah. Cool, keep making it. And be like, oh, this is weird. Hey, is this right? Like, and how do you clone yourself and move on, right? Like
cloning humans turns out to be super hard. You have to like train everyone from childhood up. It's such a pain in the ass being a parent or a teacher. Robots, one Tesla fucks up, they all learn never to do that again.
Right.
So like, to me, this is going to be just a very exciting transition because
I like you to pick the food example. I mean, the food is, someone will be upset, but like I feel like one of the slowest moving in terms of manufacturing change of just high mix in the food industry is like, oh, we actually make a different cereal every other month, right? It's just like it's yeah.
Yeah, no, I really think there's room for several revolutions in food. Yeah, and automating the production of meals should be, I think, one of the top targets for robotics now.
And it is, and people are like, there's some like really credible efforts going on right now.
No, it's super exciting.
Yeah.
So you're trying to raise your kid in the shop.
Yep.
In the prototyping shop. How's that going?
Kind of great. I mean, I don't know. You go through fits and starts of like, how much do you want to push it or not? Like there's awesome moments where it's just like, well, I mean, we have a factory, we can just build them, right? I'm like, sure, let's go right now.
Yeah.
And there are moments where he's just like, oh, yeah, I can. Your lunchbox is broken. I can spot weld that for you. Like, the parent. Yeah, I'm like, yeah. Go do this thing. And there's also a lot of time he just wants to read books or do whatever and hang out, and like that's cool too. And I don't know, just try to enable all things being possible. And
well, I'm really interested in this because people think I would be raising my kid in a shop that makes robots, which I'm not doing. And she has no interest in robots whatsoever. The rebellion against whatever your dad is doing is like just a fact.
Oh, we have that too.
Yeah, but you have that environment. Kids spend a lot of time in it. It's like it'd be like I don't know, people our age growing up in a toy factory or something. Like, what's the environment like? A mess.
Well, it's not like a tool. Okay, it's kind of a mess. It's project to project. I mean, we have this joke like you kind of have shops everywhere. Like so so the basement workshop it evolves through projects you've worked on, right? And so you accumulate this detritus from past projects that then becomes what enables this bizarre broad combination in the future. Right? And that's my life. When at home there's a small CNC mill, there's a nice small manual lathe, like a bunch of woodworking stuff. It's packed into a tiny space, big electronics bench. We can do SMT assembly, we can do little things under the microscope, have all kinds of weird chemistry stuff because I was working on someone had asked me to develop a compostable whiteboard marker some years ago, and I went all the way in on to like ink you can drink. Like
why do we need that?
We don't.
Oh, all right.
Yeah, is a bit of a statement piece, but
all right.
And the real answer, of course, is not to fix the waste stream. It's to fix the object so you don't have to waste it, right? And this is where, guess what? You know what? There's a whiteboard marker that
lasts perpetually.
Well, not perpetually, but the failure mode of whiteboard markers is usually the cap gets left off, right? How often do you really run the ink out?
Okay, right.
And so, guess what? Someone makes whiteboard markers that last a lot longer. Like if you forget for a day, they're mostly okay.
Yeah.
And we're like, great, that solves most of the waste problem.
Yeah.
So anyway, separate things. But anyway, got a bunch of weird science stuff, and it meant that one day you're just like, I don't know, it's probably 4 or 5 at the time. Like, what do you want to do? It's just like we made a little tanker truck in the shop. It's like, well, I want to make some gas for the tanker truck.
Yeah.
Like, okay.
Yeah.
And so you pull out the chemistry set and like set up a bunch of racking and a distillation column. And no, it's not gas, but like you pour a bunch of goop into alcohol and goop into a round flask and boil it off and through a tube and like extract the alcohol back out and like, see, we can light it on fire. It's like cool. I could have put it in my little truck and drive it around the room. Like, okay, we're not going to tell anyone what's in that bottle, but like, I'd like you're not going to drink it. It's going to be fine.
Great.
And so there's being able to do stuff like that. And so there's that. And then I share a big industrial workspace with my friend Han in Soto, where that's where VMC and CNC lathe and big fab table and welding and we fabricated this art project for my childhood friend Naomi. She has a big commission at a school. It's like an elementary school in Oslo. It's 13-foot tall intersecting steel plates, and might get to do big stuff like that there.
Cool.
Where you have space and cranes and means that, for the kid, he hangs out there a bunch, and it means that,
How old is your kid now?
he's 8.
All right, great.
Yeah, so Valentine's Day is all like urethane die-pressed, like fancy metal things that we powder coat, because, why not? What are we doing here?
Great.
We have lasers, he knows how to make, I don't know. And he, whether he's into it or not at any given point, and I try to like, now we're at the point where like really try to, let him
follow his own interest.
follow his own interest. But it's also awesome when like you're in there and, someone else is like, oh, doesn't the CNC machine just like poop those things out?
Yeah.
And, at the young age of whatever he was, he's like, oh no.
Yeah.
If you want the CNC machine to make something, first you have to design it on the computer, which takes a long time. Like, clearly the boring part for a kid. and then you have to go like find a piece of metal to make it out of. Then you have to go back to the computer and tell the computer what you got. And then you have to like go to the machine. Then you have to tell the machine where the thing is, and then you hit the button. And then I hear if you want to make another one, it's pretty fast, but we never make more than one.
We never make more than one. Oh my God, that's great.
So it's like, oh my God. But yeah, no, it's also cool, like getting him involved in production things, right? So with this paper printing project that I was working on, or holiday things or whatever else, and just having an understanding of you multiply out time and like what it means for repetition, and he loves helping and being useful, and like there are things that he can do that, and you're like, oh yeah, great. You like run the laser and cut these things out for a while. Like here's how you change the sheet, close the door, hit the button, stack them up like this.
Super cool.
It's awesome. And he's so proud of like to be able to do that, and it's awesome.
Great.
So I don't know.
Drop my kid off. She can be useful.
Yeah, anytime.
What about like going back to the perception framework you built? If that exists, and all the other stuff that we take for granted now, like SLAM and stuff exist, what's the next thing that's missing that needs to be built? Like, what do you wish you had for robots to just go nuts and take over the world? Like, what are they missing?
I think that when we really feel like we have the capabilities, we'll be able to assign them something to do. Yeah. But there is a assign them something to do management problem. And
like with people.
Yeah, with people, and I don't know. I mean, I walk into the shop and go like,
with people, you kind of got to convince them that they want to do it. Mm-hmm. Robots,
they'll just go do the thing. So there's a big integration gap between here and there, like no question, right? And I think there are some really open questions around how much of it is, once we have the semantic framework, everything else can fall out and like there's some happy middle ground, and how much of it is closer to this pixels to motor torque giant models that will get you there from intent. But it's all.
I wonder if there's some kingpins here though. Like, have you been coding using like any of the AI?
Of course. I mean, you can just stop the sentence at "Have you been coding?"
Yeah. There you go. Yeah. So it's something flipped there where it's just like good enough that it's like I'm better off just like trying to talk to the thing and tell it what I want and see if it works, and then which is kind of what coding always was. But and that's what I'm getting at, like what's the right abstraction layer, right? And that's where, hey, we can ask just visually, is the forklift blocking the aisle, or is the door open, or is the part located correctly? But like finding that right level of abstraction, and that's and then building all the pieces around it. Like you kind of have to settle on, and it's a moving target, right? Because as parts on either end get better, you can shift the target to one way or another, and you're trying to. Mm-hmm. But as a first order, you could say like if I were training a human, I would just be like, hey, just do this, and I would show them, which is kind of the cobotics or whatever idea of like, just let me show you what I want, and then. Yep. You can ask some questions, you can try it, I can give you some feedback until it's like looking good enough.
There's also a version, and that's farther out, but there's also a version of, let me just tell you what I want. Yeah. And let me tell you in a specific way, right? Like there's there's patterns. Take the thing and put it in the place, right? Well, I don't know what thing is, I don't know what place is. If all you have is a simple model that you can ask, where's the thing? Blank, where's the place? Blank. And you have a bunch of known patterns, and and this is where there's some there's somewhere between this like programming abstraction layer and
I just think,
magic.
I think
And
we're
then-
going to kind of get all that for free.
Right. Well, that's the thing. But the like, what is the thing and where is the place?
Yeah.
Like that's what we can do today.
Yeah,
Right.
yeah.
And so we do
Okay,
that
cool.
today with Groundlight.
Yeah.
We can identify that thing in the place. And the problem is they're the big models that do it. And we like to say we're going to get there for free. But
Yeah.
you ask 4 big models, you get 3 answers. Right. And that if you're lucky, right. And
Okay.
then you get these like amazing
Yeah,
cherry picked stuff. But it's
Yeah,
just
okay.
anyway.
I see. So what do you call this product?
Groundlight.
Groundlight is the product?
Yeah.
What's the name of the company?
That's same.
Groundlight? Okay,
Groundlight.
cool. Worth mentioning.
Worth mentioning. Yeah. No, I'm bad. bad founder. Mention the company. Mention the company.
By the way.
By the way, you can find this all at groundlight.ai.
Cool. I guess what I think is that, there's this kind of little battle going on in some sense of whether we're going to take a giant model that knows everything and then try to pare it down to the task at hand, or we're going to build a little model from the ground up that's built to do that task at hand. And right now, I think there's certainly strong opinions on both sides of that. And so like the thing you describe of, if you ask 4 LLMs to tell you the answer to something, you can get 3 answers. It's because we're not doing a good job of constraining those models to the task at hand. And I think that we have to solve that anyway for all these other contexts that I think we're kind of going to get it for free with robotics.
And the question is how good and when, right? It's
right, exactly.
And then like when real things have real
And
consequences.
we're probably at 80-20 and we need to be at 99-1.
And the way that we think about that is, we have this escalation architecture where we go from like model to model to model to human, right?
I like that.
If we don't have to get to the human layer, great. Like we actually hope that VLMs would be better today, and we would have to scale humans slow. Like scaling humans sucks, right? Like scaling models is awesome.
Have you tried? I mean, it wouldn't be hard to make the case that this escalation model thing, I don't know if it's being used in other contexts, but it certainly would make sense to like do that for content filtering in social media or something, for example.
Probably
like,
is.
Probably
right. But the question then becomes also, how do you close the feedback loop? And I think that's where what we're doing is a bit different in that we close that feedback loop in real time. And typically, you look at like kind of conventional active learning, and that's where you'll say, oh, hey, we're going to take some examples that we weren't sure about, and we're going to add those in and train the model. And then so the next round of model deployment in 3 months, whatever, like great. I don't know whether it's like hyperactive learning or something else, but we do that in real time. And so as soon as you could ask the question, like, is the person wearing a microphone? Not sure. The answer is yes. Ask it 4 times, that confidence would just go up, and like we'd stop asking.
Yes.
And we integrate those in fractional second.
Yeah, great.
So that's I don't know.
It's sort of the analogous thing to retrieval augmentation for LLMs.
It gets into the zone.
Yeah.
But I don't know. It's funny. Like you bring up the coding side of it too. Like have you coded? And this is what does coding become, and how does it end up? And you talk about kids and whatever else too. Is like what do we want to teach, right?
Yeah, right.
And like where do we want to go with that?
I don't. The weird thing is, and I haven't got any way of getting a good sense of this, but like when I talk to coders, they're like, oh yeah, I just use Claude, and it fucking writes all the software for me, and then I fix a few bugs and we're done. Whereas like people who don't code still can't do that.
So I teach a class at UW. It's like a hardware software design. It's in a master's program there, and it's interesting. I don't know. We flipped the program policy last year for my class at least. I can't vouch for the rest. I was just like, look, it's not you're cheating if you use GPT. Like you're failing if you don't. Like you just like it is assumed that you're going to use this. You have to understand your code. Here's how you debug the code, because you go from these labs that were, some of them, like a lot of it's copy paste anyway, right? Like what are we doing? It's like we're going to stack exchange copy paste, and there's a whole interesting question. And so this is, like in the PicoBrew was built like as an engineering team, hired a ton of interns, grew them into the engineers we want them to be, and it was awesome, right? And then they, spread wings and all the things. Like the most leveraged thing you can do is to teach.
Yeah.
Like that's like the most leverage impact you can have on the world is to
Man,
teach.
I don't know if I
right?
believe that, but okay.
Okay, you don't believe it.
I don't want to believe it.
I don't know. I believe it.
Okay.
I worked at Microsoft for a long time.
Yeah.
I did things that I can say moved like U.S. electric power consumption by like fractional percentages on like a like really directed crusade, like big lever, awesome.
Sure. Yeah.
But how about teaching people to do that in all the places, right? Like you can't be all the places all the time. And
Well, if I thought I could do that, I would believe you.
fair.
All right.
Okay, fine. Maybe it's look,
maybe
it's just optimism. But
yeah,
anyway,
that's great that you feel that. Though. And also, hold on, just stop.
Yeah.
There. I'm not right. I just feel that way.
Yeah.
It's
you might not
awesome,
be wrong either.
It's awesome that you feel that because I think it is what we need humans to do. People are wound up about robots taking their jobs and whatnot, but this is the thing where we're not being honest about. Like we're never happy with teachers, meaning even if we like the ones we have, we don't have enough of them.
Oh yeah.
And so fine, let a robot do your menial, boring, dangerous, repetitive job and go teach. Even if you only have one student, that would be amazing.
Or one thing to teach,
Just
whatever
teach
it is.
Any one thing.
Anything.
Teach anything. I don't even care what it is. Just teach. Imagine a world where everyone who right now is between age 22 and 62 that's doing any job in the world stops doing their job and just teaches. That's a third of the population.
That's a lot.
And they all become, now we have a 1-to-1 student-teacher ratio for everything in the world. For every student in the world now gets a teacher full-time. That'll be much, or however many they want.
Right.
Why wouldn't that world be more awesome and better and worth pursuing? I don't know.
Also look, teaching's not for everyone, and teaching all the time is not for everyone either.
Fine,
I can't only teach,
Yeah,
right?
me
But
either.
I would go crazy. But I love doing it in a certain amount.
Okay, fine. Do it as much as you want.
And in a way where I feel like I have something unique to add here that you're not getting some other way, and how to do it. But anyway, we get to it's real interesting. How do you want to teach people to build things, right?
Okay.
And so with coding with AI, okay, great. Coding with AI. How do you work on understanding and debugging, and what is the abstraction layer? It's somewhat I think maybe middle management is going to be a productivity skill, maybe now, right? We've made fun of it for years. It's take specs from the customer and the engineer, or whatever. But we're kind of pushing on a world where a good manager all of a sudden has these AI agents that are able to execute on its behalf and knows how to, and weirdly, because of probably accidental, but conversationally trained LLMs, guess what? They respond to the same kind of coaching that people do, right? Because we're going to sequence predict what people do. It's you know how to coach a person, you can coach a computer, right? And that, I don't know, that teaching how to do that, and it works with people too. It's pretty powerful. But there is a whole you or I could go write a bunch of code with an LLM and then quickly poke in, oh, that's not right. And they're just we don't even think about it, right?
Exactly.
But without, how do you learn those skills to start with? And how do you, and some of it's just exposure, right? I go back to this.
Yeah, and what's the modern version of that?
What's the modern version of that? How do you get enough?
We learned by crashing and rebooting.
Yeah,
and now you would
sticking fingers in electric sockets and all the stuff.
Yeah, basically try everything and throw out what doesn't work.
Yeah.
Whereas if you were starting now and you had you had a giant LLM that can code helping you, what do you do?
Yeah, and so
do you ever learn? I know that inside my head, I'm still doing the same thing. I'm taking the thing I want, breaking it down into a set of logical steps, and then I'm asking the computer to do those steps for me. Whereas you may never learn to do them.
But then you watch people get stuff done without even breaking it down into steps. You're just oh, that's
maybe,
pretty good, right? And and maybe you just have to roll the dice. If we're in a world today where you can roll the dice 4 times and eventually they come up with the correct list of steps, that dice rolling process is going to get better for sure, right? Their feedback loops, it gets better. So I don't know. It's
exciting.
it's an interesting thing. I don't
I
know.
also think it's interesting that, like, in some sense, the first people who lose their jobs to new technology are always programmers, right? Like any programmer has been like forced to obsolete their skill set like every 2 years for the entire career. They just take it for granted. It's like, oh, we don't use Sybase anymore. We use Oracle. Oh no, we don't use Oracle. We use MySQL.
Right.
Oh, now we're using Postgres. Oh, now it's Mongo. Now it's like boom, boom, boom.
Yep.
And it's just like you just have to relearn your job all
Yeah.
the time. And that's just database. Then there's programming languages, and there's like all these things change so much so fast that that's like the one career that's used to it. I'd say. I mean,
right.
you occasionally end up with like a, crusty old gray-haired dude who's like still doing COBOL or whatever, and like probably getting paid millions of dollars because he's the only one left who can do it.
Yeah.
Or whoever writes print drivers for HPs or something. But I think there's like this embrace of the progression that programmers get, even unwittingly, that it doesn't exist in most other careers. And so, I don't know. I think it's like
Yeah, it's interesting. I never really thought about it that
Yeah.
way, but I see that.
Yeah, they're the ones. I mean, and now, I just think about the things like I was talking to somebody the other day, like I used to have strong opinions about like, I don't know, object databases or kernel, microkernel versus monolithic kernel. Like I had to like have strong
Right.
informed opinions
Yeah.
about this stuff. And I just don't give a shit at all. I'm just like, does it work? Fine, go.
Right.
It's so weird to think of like, and I think about this, I was talking to somebody else about this recently, I've always thought that like when, again, like when you and I were kids, like computers were like these very expensive 8-bit machines with no memory and you had to engineer everything to be efficient and 100% accurate
Yep.
at all times. And as we got more resources of any kind, storage, memory, processing
Extended
power,
basic cartridge.
you
yeah.
basically waste it on making things easier for the human. And when you look at biological systems, they're like 99% error correction. Like you and I are just a pile of cells that are dying off
Yeah.
all the time, being replaced by new ones, and it still kind of just maintains forward momentum. Whereas like, and what I think this is going, and I think LLMs are sort of like the extreme expression of this, is that like, okay, we finally have so much computational ability, we can throw it at just like do everything and throw out what doesn't work. And that's kind of what an LLM is and what deep learning is.
Yeah.
And so we're getting more and more to where our computers are built the way biological systems are. And I think that that's going to pay off massively in robotics.
And hopefully it, intersects with free energy and all the other
Yeah,
things.
for sure.
Because it's just like,
Yeah.
there's the whole other side of it too, right? Around efficiency and things like that. They're like, actually efficiency is not horrible in a lot of ways.
Yeah.
We have other problems associated with that, but, optimistic on that front too. But yeah, no, it's.
I remember a few years ago, I tried to talk you into this idea I had for making a robot that that installs fake eyelashes.
Oh yeah, last
Someone
bot.
has done it now.
Yes.
There is one.
Yes, I think I sent it to you.
Oh, did you
Yeah.
send it? Yeah, you sent it to me. A couple people sent it to me. Anyway,
Yeah, I saw a
I
bunch
haven't
of
got to
companies
see
that-
it yet. I really
No,
want to
I
do that.
haven't either. Yeah, no, last bot, just like a M1A, just like.
If you could build any robot in the world, like you didn't have to do anything
Oh.
else, like what would you want to build?
That is I like, of all people, I should have this one
It's okay.
off
No,
the
after.
top. Yeah, I mean, if you're like, there is the whole, like, if you can build it, and I guess that it's funny, it's like, why do we have all these crazy humanoid robot companies? Because I guess it comes down to like, well, what would you build? Well, there's this, that. I guess if I could build anything, I would build the super general purpose one, and we know that this architecture we live in mechanically has all kinds of weird compromises, but we've been able to do everything we've wanted to date out of it. And
the rationale for humanoid, I think, is just that our built environment is for humanoids.
Yep.
Because of us. And so you don't have to rebuild anything for a humanoid because they can operate kitchens and cars,
Right.
and you can transport them on.
But yeah, like if I could have anything I wanted,
Subways,
it'd be there's a decades
Yeah.
or millenniums cost of like changing the built environment, and like, do we want to live in separate environments? So like, actually want to be able to see the robot and enjoy the robot. So
Like
it's going to be in my
every
environment.
robot I ever built was a pain in the ass to travel with, because you had to
2 Pelican
take
cases.
it apart,
yeah.
pack it up into Pelicans,
Yep.
and check it and all this, and it's overweight and all
Drag
that.
it through
Whereas
hotels
like
in
if it was a
Vegas, yeah.
humanoid, you could just buy a coach ticket, and it could just like get on the plane, and then like everything gets easy.
Yeah.
So I think that is the rationale.
Yeah. So it's like, as much as I'm like, what are all these companies doing humanoid robots? Like,
Yeah.
I guess if you could do anything, and so I guess if you're going to just take a moonshot and go for it, then like, why not?
Yeah.
Let's go there. But I don't know.
Well, it seems like there's a good amount of investment going into building some humanoids now, and hopefully we'll get armies
For
of
sure.
them.
And I mean, I'd probably build something else in between. Maybe
Yeah.
it's a Centaur, maybe it's some other weird thing.
Centaur.
But,
Yeah, not a lot of Centaur bots
no,
being built.
I
don't
think
know
there
why.
are at least a couple. But it'd be something that is part of my life,
Yeah,
right?
okay.
And
Yeah.
it's could be an extension, and you're talking about like, cloning humans is hard, right? But if we want to get all sci-fi dreamy about it, sure, why not? Let's go. And be able to start having robot extensions that can go off and do things, and for you to think about. And
I just want a humanoid robot to ride this Peloton for me. I mean,
and
if I could
just like pump the results right into you.
It just goes, it just rides the Peloton and gets a high score.
I mean, I think we can do that for you.
Yeah, that would be. Like,
I'm like looking
is
around.
there a cordless drill we can hook up to the
I feel like
chain ring here?
I feel like we could just like hook up the monowheel right now, and
Yeah, oh yeah, there you go.
We could rack you up some points while we chat.
Yeah,
Like,
we
this
could
is-
make
do
it's
this at the
totally
same
doable.
time. This is not hard.
The one I thought of this week is that I want to make, what I want to exist, I don't necessarily want to take the time to make it, is I want a drone that can go change those light bulbs. Like, how come I can't get that on Amazon? Like, a
a good
drone can
question.
fly,
Yeah.
it can turn, like a suction cup could grab the light bulb and turn. Like, what is missing here? I think that should exist. Somebody should build that for me.
Yeah, that's not crazy.
It's not crazy.
Well, especially because we
I
could
don't want it to hit the. I really don't want it to hit the sprinkler. So that would be the number
What's cool
one.
too is there's a lot of torque things, but like we can
Yeah.
get creative about that, right? It's a
Yeah.
one-time mechanism, so you could have like a sprung mass that
Sure.
you basically you get it up there,
Yep.
you pop the spring, it like impulses itself and
Yep.
like whips the light bulb around and comes down.
Yep.
Put the new light bulb on,
Yep.
spring the mass,
Yep.
and just like whip the thing in. Like you could, we should build that.
That should totally. I think that's a hit product.
I mean, it's more than an
I want to make the
project,
infomercial for it.
Yeah, for sure.
Sprinkler bugs me though.
It does, but
Yeah.
so it's funny, like things like that. I've been going to a lot of trade shows recently,
Yeah.
like varied trade shows to like,
Cool.
where are the right places for computer vision? Like went to Automate or Modex for the logistics industry or medical device manufacturing. Like choose your thing. What the actual worst part of going to trade shows as a startup founder is?
Yeah.
Like the actual worst part?
See things you could do.
Exactly. I'm just like every 10 feet, I'm like, oh, well, like why isn't someone doing this missing? Like this
Yeah.
would be eyes on the prize, eyes on the prize. Like it's
Yeah.
just like so. There's just still so
Yeah, yeah.
much cool. Like we're out of ideas. Like there's just so much cool stuff to build. And like
Yeah.
it's every one of those. Like if you could have anyone you want, sure. But like realistically, like, you don't get to apparate anyone you want,
Yeah.
right? Like you don't get to just be like, so yeah, you do build things like Lashbot, and you do build
Yeah.
things like, and you get this collection of things where people have built like they've built their problem solver, and the weird,
Yeah.
all those like cool weird patents from the 20s and 30s of like bizarro mechanical inventions to they're just like, oh yeah, that's a
Imagine if we had like a humanoid robot in your shop. We just aim it at those old patents. Say, hey, go build one of these things. Go build one of each of these crazy perpetual motion machines.
right, just like reduce it to a thing.
Yeah, just build them all.
It'd be fun. I don't know. I love watching robots work while I do other things.
Yeah,
like that's just like
So satisfying.
there's so many instances of that for me where I remember the first time we had this CNC lathe, and like the first time we got it to pull a bar, and it was just like I think the robot just bought lunch. We should go somewhere nice. And we just like left the shop, came back in an hour and a half, and like there were parts in the tray, and it was just like,
good.
oh yeah, this is
So good.
super. Actually pushed a bar, didn't pull a bar, but yeah, that's like, or I did a project for Kabu, they make hats. They make a lot of clothes. Like
Oh,
they make a
okay,
lot
I
of
think I
clothes.
know.
I basically like built a robot to like do like the stainless band that's inside one of their hats, and just
Oh.
like the thing runs from coil. It's beautiful. It makes these things all precision. Like it's totally
Yeah.
overkill for the problem. But like for me, I would rather spend some amount of time building a machine and then let the machine run as I would just like make all the parts and just
Yeah.
do the thing. And it's a trade-off and whatever else. And so anyway, but it's just like it's so satisfying to build a robot for a special purpose task and then just have it run
Yeah.
and run and run. And I don't know, I'm soothed by it. I'm just
Yeah.
like, I mean, like it's that moment of being mentally freed up.
Yeah.
And it's just like that, like,
Right.
oh, I
Yeah.
just unlocked capacity, right? Like now I can go do this other thing.
sure.
I don't know.
It's a multiplier.
It's fun.
What else is interesting that we didn't talk about?
Oh, I don't know. What's interesting in your world? So many things are
yeah,
interesting
any
in your
questions
world.
for me?
Yeah. What's
So I've been going to different labs, trying to see what's kind of possible, but not yet on a commercial track. I was just at the Idaho National Labs. They have a lot of amazing stuff going on at that place. And it's such a weird situation. Like they have a couple of nuclear reactors that were built in the 50s and 60s,
Yeah.
just hanging out there. They use them for testing. They have 3,000 engineers working on all different kinds of nuclear stuff, testing fuels, fuel cycles, different core architectures, everything. And it's this wild situation where like they're not allowed to go build any actual reactors,
right?
but we've kept these people going for decades and decades, just learning and keeping an eye on existing reactors and testing little, Band-Aids and things we can do to improve them and stuff like that. And I'm like, wow, we have everything we need to just go build reactors en
Right.
masse, and we're just not
So
doing
why
it.
aren't we doing it?
Yeah, I think that it's an exciting moment because there's a lot of positive signal that sentiment is changing. Congress has turned around and told the NRC to get on building modern reactors, which is super interesting and not like completely bipartisan support of that. I don't know how that happened. And I think there's and I think the fundamentals are in place now or coming into place to really support that, because we had this problem with nuclear reactors where like I'd say, the biggest industry in the world wasn't enthusiastic about them. And it happened to be the same industry that funds Congress,
Yeah.
or at least the elections that staff Congress. And so I think it was just really hard to get anywhere. No one was winning elections running on a platform of building nuclear reactors, and nobody was getting their campaigns funded for that. So you could expect nothing to happen for decades, which is basically what happened. And so, but the interesting thing is what's flipped is the biggest industry is no longer the oil industry. Biggest industry is big tech. In the last few weeks, big tech figured out, oh shit, we need a metric fuck ton of energy. It needs to be clean and it needs to be cheap. And there's only one answer to that, because they need it to run 24/7. And so I think the tech industry has just woken up to the fact that they need nuclear reactors, and they need a lot of them, and they need them fast. And they will run Congress.
Yeah.
And you can see they just figured out how to become vice president, if not president. So that's a very interesting set of, I think, like tailwinds that can turn this around, and hopefully quickly.
Do you think tech industries become power companies?
Yeah, 100%.
Because it's like at this point, it's funny because like,
Yeah.
once upon a time, software was I was talking to a friend about this recently, and it was just like, oh, it's like margin of software, amazing. Well, now we have to buy a lot of GPUs and like data centers. Like watch this all, like, oh,
Yeah.
we're going to heavy CapEx. I'm like, sovereign supply chain, do we need power? Okay, let's go.
It's not even a question.
Yeah.
It's already happened, because all of the way energy industry works is with these offtake agreements where you
Right.
basically contract
Right, you
decade
contract it.
out,
Fair enough.
or 2 decades out.
Yeah,
and big tech already bought it. It doesn't
Yeah.
matter how many GPUs you can get. You can't get the power.
Right.
Microsoft, Amazon, Google, Facebook, they own the power.
They're effectively already JVs with the.
They
with
already
the power.
are.
Yeah.
So
yeah, fair enough.
So
Fair
those
enough.
are the
You're right, yeah.
people who have the who have the access to the power, and all the new capacity going up, they're going to buy it out before you ever find out it's happening. So, you know, it preserves the existing monopolies or whatever you want to call them, the existing oligopoly of tech industry. But if they force the building of nuclear reactors into reality, then they'll be saving the world, and I think that's worth a lot.
I think so.
So, yeah, so they can fuck up our kids with social media if they want. As long as they build nuclear reactors, I'm fine.
Well, as long as they have power. Yeah, that's pretty good.
So anyway, yeah, I don't know. I get really wound up about energy because I think it's so fundamental. And when I look at almost any other problem, like, cool, I'd love to solve that, but we got to solve energy first before it makes sense.
Well, there's kind of the, you know, choose your free variable is like is a phrase I like in a lot of ways, because you know, solve any problem. Like, great, what do you want to at what cost, right? Like like free energy solves water, right? Like
exactly.
Free energy solves food. Like there's we could, well, you can't you know, pull salt out, like
free food solves nothing.
Free food solves nothing, right? But it gets you a sales pitch or something, right? That's usually free food gets you a conversation. Yeah, that's all. So, but yeah, and so it's just like, what's your thing, right?
Yeah.
And like in that, so I'm all in on like, many things are fixable at that point. But
yeah, it gets exciting if we just grow energy capacity and we can find better ways to do it. So yeah, I think that's one. I'm also like, you know, really excited about trying to figure out like how we scale up on just doing innovation in general. Like, how do you get more of what Silicon Valley was doing? I think Silicon Valley got very myopic and focused on problems it could solve with software. And I think that's cracking open now. So we can start to go after other problems. And I think the people who are going to be good for that are not necessarily in Silicon Valley, but there is a big problem with, so a lot of engineering talent around the world, a lot of different kinds of industrial experience, all that stuff is super valuable. Problem is that in vilifying Silicon Valley, I think most of the world has failed to learn the important lessons about what works and what they're doing right. And I don't think we're going to succeed at scaling any of this up if we don't steal the best lessons from Silicon Valley and build on top of them, instead of just these cultural backlashes against Silicon Valley, which is all. And so for whatever problems or complaints people might have about the tech industry in Silicon Valley, we won. Like, we did things that worked better, scaled faster, changed the world faster, made more money. All by any metric, we're winning. So I'm not saying it's right, but I think we have to be honest with ourselves about like, okay, what did Silicon Valley do that worked? Let's steal that, and then improve on the things that we think they sucked at or did wrong. And that's so important because in order to scale up, we have to diffuse out of Silicon Valley. We have to get people around the world in on advancing new technologies into the world. And we have to get investors around the world in on the models that work. For all the complaints about venture capital, it's winning in a way that almost nothing else is. So let's make venture capital 2.0, but big power steal what worked. So those are the things that I'm trying to figure out. How do we get ahead of that and get people to really go far fast and learn from what
finding that right mix of like enablement and urgent forcing function. That it's like it's almost comical, but like I go to Europe a bunch. They're really they're real low-hanging fruit for mockery because they're so fixated on this kind of top-down direction and control and trying to regulate things that don't even exist yet, that it's sort of laughable from an innovation standpoint. Even though we can see the results, they seem so just like dogged about sticking with it, and that's very frustrating.
And what I want them to do is wake up and see like, okay, look, there's a time and a place for regulation. Let's do that, but let's do it after we know what we're actually regulating. And I think that they're not open to that. And so, but look, Europe has a lot of amazing engineering talent. You know, they have super smart people, and they have, I think, motivated people who are stuck in cultures that are not good for innovation. And that's great if what you're doing is like, you know, running a factory in the 50s, but we're not really doing that now. So we really need these people to kind of look, again, I'm not defending anything about Silicon Valley except that it works. So let's steal the part that
so
works.
how do we bridge the 3,000 people like keeping the lights on at the national lab, and like they're learning, they're doing cool stuff.
Right.
Like how do we bridge that?
And
not
even
just
that,
Europe,
that is
right?
the conversation. And never mind Europe, even in the US, there's a national lab there, 3,000 people. They're all doing incredible work, but they're unable to translate that into commercialization by and large. And at least certainly not at the scale that I would want to see, and with the kind of innovation that I think is necessary. And so we need those people, coming from the tech side, even with, even having worked on some nuclear reactor projects, like we didn't have what they have. How do we bridge those things? And that is happening to an extent. I mean, they are working with all the commercial reactor projects to the extent they're allowed to. But, I want to see, like, how do we build those bridges? How do we scale all that up? Just do 100 times as much of it. And,
Should be good.
Yeah.
Yeah, no,
So anyway, that's,
these are real
a
problems.
little rant, but kind of what I'm fixated on.
What's the, what have you learned in the last week that has delighted you most?
The first thing that comes to mind is that maybe the last month or something,
Pick your time period.
I completely jettisoned Google. I only used Perplexity. And I didn't want to before that. In fact, at first I was kind of annoyed about some of the UI choices Perplexity made, but it's really won me over. I don't use ChatGPT except if I want to like go do a thing that I think is specifically good for, but for all search, I use Perplexity. And it's awesome. And the weird thing about it is like, just because like I'm the kind of person who, when I'm texting, I do perfect grammar and punctuation every time, like complete sentences. Like there's no like, IRL, whatever.
Right.
I'm not doing any of that. I am writing complete sentences. And I don't do that with Google, but with Perplexity I do. So in Perplexity I write complete sentences, all my questions are question mark at the end, like everything is, and I like that. I feel like I'm able to have, and I love being able to have the follow-up questions that are contextual. To me, I'm really thrilled about it. And I'm so happy that like my life will always have something at least that good.
Right.
And so I find that I use it for things that I would, if I had an exploration that I wanted to do, I'd think about, a lot of them I would say, because I know what, in Google, it's like, okay, I'm gonna ask Google to tell me about, what is toothpaste made of? I'm gonna open 12 tabs. I'm gonna go scroll past a bunch of fucking pop-ups, and I'm gonna scroll past like ads and, for toothpaste and shit, which I know I'm gonna be getting for the next 3 weeks in my targeted ads and on Instagram and everything. And I'm just gonna have to, I'm gonna close 6 tabs. I'm gonna end up with 3 that I got a long form, and I'm gonna run out of time to read it. So I just don't even start.
Do you not feel like you're losing anything to the filter? I mean, this is the...
In Perplexity?
Yeah, or in general, right? Like when because this is the whole, it's like Googling the answer versus getting a book. And this is, like I've seen this with, like, interns, new engineers, things like that, where they go and they design something because, and guess what? They were able to Stack Overflow the exact question. And so like you change some parameter, why isn't this working?
Totally.
They're like, well, you designed the circuit, like how do you not understand that like there's an impedance mismatch here or whatever? Like, it's like, I copied cut and pasted it, and like you get the thing, like you don't, and I get it. When you have to go search for the answer in a book, you have to read all the stuff around it, and you're forced into it. And I even myself, like I catch myself doing this all the time. Like I love like really understanding things, but
Yeah.
I'll punch it in and I'll like see the first line and blah 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 because what else did it say? Like, oh yeah, I didn't even look, right? You know, just like,
Right.
like do you?
I think it's so if I think of like, you know, sort of two major learning styles. Like I know, like, you know, on one side you've got like professors.
Right.
Professors read all the books.
Yep.
And they know everything all the way down to impedance mismatch. They're never going to make that error.
Yeah.
Hackers didn't read any of the books, but we tried everything, and we discovered impedance mismatch. We went and, you know, read what we had to understand that. And so there are two ways of like arriving at the same, not the same skill set, but the same result in a way. And you know, my learning style is very much hacker, but and hacker kind of sucks for a lot at the beginning, but since you and I have been doing this for decades,
Yeah, you do it for long enough. You
we
develop
know
a
so much
totally
that the
different
professors don't know,
understanding.
and we can do so much the professors can't do, that I think it's if not legitimized, a very effective learning style.
Right, but to be able to do the hacking,
Yeah.
you have to have like a starting point and an inexact answer. And the
Yeah.
problem today is like you can go and you just get the exact answer, so you don't have to hack to it either, right?
see.
Like you just get this exact answer. Like,
Yeah, I think that's
here's your thing.
now
and then like you go punch that in, and like you didn't get something that was close. Like before, like there's an example in the book that's close enough, and you had to read enough of the paragraph to understand like, oh, this thing affects this thing. Okay, I'll start tweaking these things till it works.
Yeah, but I think that kind of is just like, it's like abstraction layers, where it's like, you know, you and I started like with machine language and then basic, and then like, you know, C++ seemed like practically like English, and then the next thing you know, we're in like fucking Python and JavaScript, and we're like, oh Jesus, I don't even have to know what's going on. And then, you know, now it's LLMs, and you're just like, build me an iPhone app that looks kind of like this other one, but make it blue and sparkly. You know, like that's all the coder needs to know. And so like it kind of levels you up for what you can build with output on the output side, but you're sacrificing like the fundamental knowledge. And so I think the better the building blocks get, like right now, like you get a PhD in computer science, you don't know how to like make a sorting algorithm. You don't need to, because it's just a Lego brick in your IDE.
I guess it becomes the like, you know, like obscure German philosophy that
exactly,
like,
that's
you
what
can
you
feel
and
like
I
a more
are.
enlightened person, but like guess what? Like it actually doesn't.
Yeah, I'm like,
you don't actually have to understand like,
but the Austrian economists were so right about this one of obscure things. So it's so I think there's a time and a place for both, and you kind of want both, and you kind of want some overlap, but eventually all of us die off, and all that's left is computers. And the computers, if we build better models, they will know all the way down, and they will pick the best sorting algorithm, even if they don't tell you why. They could tell you why if they want, but you know, I think having the knowledge in there, like right now, like you and I are used to this experience where like all the knowledge exists in the world, but at any given moment, what's effective is what I have in my head, have experience with, or can get my hands on readily.
Exactly.
Whereas you and I are going to be powered up to the point where like, okay, now our toolkit is all the knowledge in the world is at arm's length to us, and we have the experience and the context and the wisdom to like know what to build and why we shouldn't do this or that, but and what questions to ask and not ask. So I think we'll be useful for a while, whereas like the interns might never get that, but they will. But hopefully by the time they get to our age, let's say, the computer models will have developed to the point where they can cover you, like they'll have perception.
You know, I guess that's the question is like is the why important, right? Like if the what gets good enough, do people have to care why? And like it's the same. I don't know, maybe philosophy is the right analogy, where it's just like it's
I think it's
you know, at some point like getting to motivations and all the things is important, but I don't know. Anyway,
what a ride. I think, I don't know, it's very interesting, exciting stuff, and it seems like a lot of people are just missing out. Like we're in a renaissance right now, and I think a lot of people are just missing out on how cool it is.
It's incredible. Like it's like we live in like pretty exciting times.
Yeah.
And I don't know. There's always there's that whole like, oh, is Is this age the age that is like better than all the? They were all there. It was also probably great.
All the ages that were awesome.
Turns out all the ages were awesome,
and
like
whoever was there was probably just missing out because they thought it was the worst.
You're right. All the ages were awesome. It's just like take the time, and it's pretty good. The world is pretty awesome.